Alright guys, so we are going to take a minute and we are going to review the power check that goes with EE1. This is also the power check that is going to, or the objective that's going to be associated with the exponent rules. So out of all the stuff we do at the beginning of the year, normally the exponent rules are the ones that people stumble over the most. So if you are struggling with this, don't feel bad. It's just one of those things you just have to work problem after problem after problem in order to get used to it. So if you're in my class, I did give you a chart, and different teachers teach it different ways. But the way that I teach it is by going through a chart and just being able to memorize the 7 sort of beginning basic rules to exponents. You can memorize those rules and follow them. It doesn't matter what problems they give you. It doesn't matter if they give you variables, exponents with numbers. None of that stuff matters. Whatever they give you, you will be able to work. You just have to learn the rules and be able to use them. So start off with, we're going to go with the easiest rule of all. Anything to the 0 power is always going to equal 1. Okay? So when you see that 0 as an exponent, you know whatever it is that you're taking to that 0 power has to equal 1. Alright, our second one, we're going to go side by side on this one. So we've got x squared, let's just say times x to the third. Alright? So even though this is saying that we're multiplying, because we're using the exponent rules, we actually take these two numbers at the top and we actually add those two together. So this is going to give us x to the 5th. Okay? And again, it doesn't matter if that's x, y, a, b. It doesn't matter what they are, as long as these two are matching. So they both have to be x's, they both have to be a's, they both have to be y's, whatever. As long as those are matching, you have the same base, you add those exponents. Alright, for number 3, let's do, say, x squared parentheses with a 3 on the outside. Alright, so because there is a parentheses and we've got these exponents that are touching, that means according to our exponent rules we have to multiply these numbers. So that would give us x to the 6th. Alright, so again, if they're side by side, we need to add the exponents. If they're touching and you've got a parentheses, we're going to multiply those exponents. Alright, so now, and if you're in my class, I've shown you a way that you can remember this. I'm going to write it up here. We're just going to say if they're side by side, you add. Alright, so I'll let you figure out a way that you can take these 3 letters and you can figure out a way to remember that if they're side by side, you have to add them. Alright, on this one, the way I remember it is by PM. If there's a parentheses, you multiply, like AM, PM. Whenever you see the parentheses, you need to multiply them. Alright, let's look at number 4. On number 4, we're going to do something that sort of involves a property that you're familiar with. It might just have been a while since you've used it. Alright, so in this one we have 2 different variables on the inside of the parentheses. That means we can't put these together by adding, because they're in a way not like terms. We can't put them together because they're not the same base. However, we do have this 4 on the outside, and the property that we're going to talk about is the distributive property. So not only do we need to take this y to the 3rd to the 4th power, we also have to take this x squared to the 4th power. Alright, so I'm going to come over here on the side and I'm going to say x squared raised to the 4th power, and just like up here, if I have a parentheses with the next one on the outside, I need to multiply it. So I'm going to say 2 times 4 and I end up with x to the 8th. Right? Over here I've got y to the 3rd to the 4th, so that means I've got a parentheses, need to multiply them, so we got y to the 12th. Alright, so that would be my simplest terms in order of exponential form. That's all I can do with it. I can't do anything else. Alright, let's look at number 5. On number 5, we're going to do something similar with the distributive property, but in this case, instead of multiplying them, we're going to come down here and we're going to talk about dividing them out. Alright, so again, we're still going to follow that same situation. Everything on the inside of this parentheses has to be taken to the 4th power. So I'm going to come over on the side, and because there's a parentheses and I've got this exponent touching the parentheses, I'm going to say 2 times 4 is 8. I'm going to say 4 times 3 is 12. So I've got x8 over y12. Alright. For number 6, let's do division. Let's do an x to the 5th over x to the 7th. Alright. So we got x to the 5th over x to the 7th. Now this kind of goes back up here to this one. If we're multiplying, remember I told you we're supposed to add the exponents. Well, the opposite of multiply is going to be divide. So we're going to think about this in terms of the opposite of add is going to be subtract. So I need to take these numbers and I need to subtract them out. So what I'm going to do is come down here and draw my line. I'm going to subtract these numbers and say 7 minus 5 is 2. Well, here's the catch to it. Because my exponent in the bottom is larger than my exponent on the top, that means I need to put my answer down in the bottom. I got to have something on top of as a placeholder, so I can just drop in a 1 on that one. Alright? So before we move on from number 6, I'm actually going to reverse this and give you sort of another example that we can look at. So same numbers, all I did was flip them. Alright? In this case, I'm still going to subtract these two exponents. The only difference is I'm going to put my answer up top. Alright? Every whole number, every variable, everything that we have in our numerical system has an imaginary 1 underneath it. I don't have to put a 1 under it as a placeholder here, but if it's in the bottom, I do have to put a 1 on top as a placeholder. Alright? Just one more little further explanation on this as far as division goes. If you need to, and you forget this rule, you can always write these out. So like for instance, on top I've got 5 x's. On the bottom I've got 7. 3, 4, 5, 6, 7. Okay? Anything divided by itself is just one whole. So in other words, they cancel out. So I can say 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Alright, so in other words, all these have canceled out, and how many am I left with? I've got 2, and then where are they located? They're not on the top, they are on the bottom. So I'm going to come over here and I'll have my 1 as a placeholder, and I'll have x squared. Alright, same thing with this one. I would have 7 on top and 5 on the bottom. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So I'm left with 2 x's, and they're on the top. Alright, and then finally my last one. You cannot have a negative exponent in your answer and consider it to be in simplest form. So this is the phrase that we use to remember what to do when you have a negative exponent. Any of you remember that old movie, Madagascar? In that movie, I think it's the lemurs that have their song, you have to move it, move it. That's what we're going to do with the negative exponent. So if I start this one off with, say, an x to the negative 3 over y to the positive 4. Okay? Y to the 4th, perfectly happy where it's at. That y to the 4 stays where it is. However, because we have a negative 3 for an exponent, this one cannot stay. It has to move. So if it's in the top, I need to move it to the bottom. Alright? And then just to let everybody know that it has been moved to the bottom, I'm going to put a 1 up there as a placeholder. Okay? Another way to look at this is if you have a negative person in your life. See, y to the 4th. I'll tell you what, let's make this a negative 4 and let's make that a positive 3. You got a negative person in your life, that kind of friend that no matter what happens, they're always going to be the Debbie Downer. You don't want to be associated with that person because you're too positive to be next to them. So we got to take this person that's being negative and you got to move them. You got to get rid of them, get them out of your life. So we're going to have x to the 3rd on the top. This y to the 4th is going to have to move up to the top with it. So we did it with x to the 3rd and then y to the 4th. Alright? But the phrase is, whenever you see a negative exponent, you have to move it. And when you move it, the only thing that changes is that it goes from a negative to a positive. It's in the top, move it to the bottom. It's in the bottom, you move it to the top. Alright? So now, based on all that, we are going to go through at least a couple of questions. I think we've got 8 or 9 that we're going to go through. Just sort of work through these. So again, if you get to these questions and you have issues, please find me in class either before school. I can stay after school if you want me to. We can have a discussion in class when we have some free time. And people are working on either iReady or working on other worksheets or something. We can kind of come back to this on a one-on-one basis. But you got to let me know that you're having issues with it so I can help you. Alright, so looking at this, we got from the list below, choose the correct value of. We got 3 to the 3rd power and a negative 3 to the 1st power. Alright, so in looking at this, I've got 3 to the 3rd, negative 3 to the negative 1. Okay, so the first thing I want to deal with is this negative number up here. I don't like the negative number, so going back to our explanation, remember the phrase was, you have to move it. Alright, so I'm going to have 3 to the 3rd on the top, I'm going to have a negative 3 to the 1st on the bottom, and now I need to be able to take these and put them together. Alright, so in looking at it, I've got 3 minus 1, that's going to give me 3 squared, but a positive and a negative is still going to leave me with a negative on the outside. Alright, so essentially what we're doing is we're taking 3 to the 2nd power, that gives us a 9, and this minus sign is going to have to stick with it. So our answer choice for this one is going to come out to be a B. Alright, so worst case scenario, if you're looking at this, you know that you need to take this and put them together to come up with the 3 squared. So you know at no point are you going to end up with them in the bottom, so then it just becomes a chance of whether it's going to be a negative or whether it's going to be a positive. Alright, let's look at number 2. On number 2, we got drag each numerical expression on the left to its equivalent value that is listed below. Let me slide it up. There, I think you can see everything. Alright, we got 3 squared times 3 to the negative 2. Alright, there's a couple different ways that we can work this one. One way is by getting rid of the negative, because personally I don't like the negatives, I want to move them. So if I have 3 squared on top, I've got 3 squared on bottom, because again, the phrase is move it. So we're moving it to the bottom. Now I've got 2 over 2, I'm dividing. So because I have the same base, take these exponents, I can divide them out. That's going to end up giving me 3 to the 0 power. And going back to our very first rule, the easy one, I end up with 3 to the 0 equals a 1. So our overall answer should be 1. Okay, so I'm just going to write 3 squared times 3 to the negative 2. That matches up with 1. Alright, the other way to work this is by taking these and realizing that they are side by side. So because they are side by side, we can also follow rule number 2 that says I need to add these right off the bat, right out of the gate. So I got 2 plus a negative 2 that gives me a 0. So no matter how I work it, I still end up with 3 to the 0 power, which is still going to equal 1. So no matter which way you want to go with the order of it, kind of like the order of operations, you're still going to end up with a 1. Alright, let's look at the next one. I've got 4 to a negative 3 times 4 to the 5th power. Again, you can take this and move it down, then you'll have division, you can subtract them out, or you can just say a negative 3 plus a positive 5. And if you need to, especially when there's negatives involved, use your calculator. So remember, the negative key's down here by the equal sign, so I'm going to hit negative 3 plus 5, couldn't remember the number, and hit enter. That's going to give us a positive 2. Alright, so we end up with 4 squared. At this point, we can come down and we just need to match it up. So that's going to be my 4 squared. If you wanted to, you could actually say 4 times 4 is 16 if you wanted to keep it going. So 4 to the negative 3 times 4 to the 5th, that gives us our 4 squared. Alright, let's look at the next one. We've got 2 to the negative 3 times 2 to the negative 1. So we can either move both of these to the bottom, or we can just go ahead and add them. 2 to the negative 4, and now we can take it and move it to the bottom. So 1 over 2 to the 4th. So we end up with 1 over 2 to the 4th. So we end up with 1/16. Alright, and if you'll notice, I was pausing there because I didn't see my answer choice. So let's stop and think about this one for a second, because it kind of got me off guard. We do end up with 1 over 2 to the 4th, like we're supposed to. That does take us to 1 over 16th, but if you look at your answer choices, we don't have a 1 over 2 to the 4th, and we don't have a 1 over 16th. So we have to go back and try to figure out if any of these answer choices is going to match up what we got. So I come over here on the side of this one, I've got 1 over 4 squared, which gives me 1 to the 16th. So that one matches up with that one. So this one is 2 negative 3 times 2 to the negative 1. Alright? So even if you're working it out like I just did and you don't see your answer, don't give up on it. That doesn't mean you got it wrong. You just might have to do a little bit of exploration to figure out where your answer is. Alright, over here we've got 3 squared times 3 to the 0. 3 to the 0 power is going to be 1, so I'm just going to end up with 3 squared times 1, which is going to be 9. So 3 squared times 3 to the 0 equals 9. Alright, that takes care of numbers 1 and 2. Let's look at number 3. Which two expressions are equivalent to 8 to the 3rd, then 8 to the negative 1 squared? I'm telling you, these test makers, they love throwing in some challenges. So we got 8 to the 3rd. Let's deal with this situation here first. So I got 8 to the negative 1. I've got a 2 on the outside. There is a parentheses. So in this case, that means, just according to my rules, I think rule number 3 is what we talked about, I've got 2 times the negative 1. So that's going to give me a negative 2. Right? So now I've got these two that are either they're side by side, so I can add them, or I can take this and I can move it down to the bottom. So I'm just going to go ahead and put them together. So 3 plus a negative 2 gives me 8 to the 1st power. Alright, so now I need to find everything that's going to match up to 8 to the 1st power. The first one, that's an easy one. I've got 8 to the 1st and 8 to the 1st. They match up. Alright, no way in this world is 8 to the 1st ever going to match 8 to the 4th. That's out. No way is 8 to the 1st ever going to match 8 to the negative 6. Even if I did move that, I'd have 1 over 8 to the negative 6. I'm positive 6, so that's out. Over here I've got 1 over 8 to the 6, so that one's going to be out of play. And then right here I've got 8 to the 3rd over 8 squared. So if I take these and I follow my rules, 3 minus 2 is in fact going to give me 8 to the 1st, just like if I said 1, 2, 3 over 1, 2. Mark those off, mark those off. I'm left with 1, it's on the top. So there's my 8 to the 1st. Okay, let me just rule out the last one. We got 2 expressions, there's our 2. Alright, so that takes care of 1, 2, and 3. Let's look at number 4. Alright, these are the ones that you are probably going to see on your state test, or at least the ones that are most closely resemble what's going to be on your state test. Going to give you a whole lot of numbers, a whole lot of variables, and they're going to start combining rules. Something like this is the best way that the test makers can combine as many rules as possible to make sure that you really know what you're doing. Alright, the phrase that we talk about on this one is, how do you eat an elephant? And the answer is 1 bite at a time. And all that means is that we are going to take this really big problem, and instead of trying to put all of it together at one time, we're going to break it apart into 6 little problems, and then we start combining stuff that has the same base. Alright, so we're going to start off. We got a 2 to the negative 3. Remember, if it's negative, that's a bad, evil person or number. We can't deal with the negative. It has to go. So we got to move it, move it. If it's in the top, we got to move it to the bottom. Alright, so 2 to the 3rd goes to the bottom. And all I'm doing is copying the problem. I'm just relocating stuff to where all my exponents are positive. On the next one, 13 squared. It's happy, doesn't have a negative, it can stay where it's at. 17 to the negative 1 has got to go. It's a negative exponent, so we got to move it to the bottom. Alright, 17 to the 3rd, positive exponent, it's happy, it can stay on the bottom. 13 to the negative 4, negative exponent, we don't like negative stuff, it has to move away from us. Alright, and then finally 2 to the negative 3, so that one's negative, it has to go to the top. Alright, so what I like to do is, once I get to this point, just so I don't get confused and sort of miss a number or anything like that, I'm going to go through with my lowest bases, match them up, and then progressively work up. Also going to mark them off as I work through them. So we've got 2 to the 3rd over 2 to the 3rd. So we're using a division rule on this one. So again, just like breaking it into small problems, 2 to the 3rd over 2 to the 3rd. 3 minus 3 is 0. Gives me 2 to the 0. So my very first part is going to be whole number 1. Alright. I have other stuff in this problem, so I don't have to bring that 1 over. It's basically just going to cancel each other out. So they're gone. Alright. So now I'm going to go 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. So the 13 is going to be my next base that I need to look at. So I'll come down here. This will be my second problem. 13 squared times 13 to the 4th. Alright, so find your rule. They are the same base. They're side by side, so I need to add these 2 exponent numbers. So I keep the 13. I'm going to say 4 plus 2 is 6. So up at the top, I'm going to end up with a 13 to the 6th power. And I'm going to mark those off. Alright, looking at the bottom, I've got 17 to the 1st times 17 to the 3rd. Again, just follow your rules. They're side by side, so I need to take these exponents and I need to add them. So I'm going to end up with 17 to the 4th. So I'm going to have something like that, right? Hoping at this point you're hollering at the screen, no, what are you doing? So if you remember, I do have 13 to the 6th on top, but where are my 17s located? They're not on the top, they are on the bottom. So I need to put my 17 to the 4th on the bottom. Alright, so 13 to the 6th goes on top. I've got 17 to the 4th on bottom. And when I check it with my answer choices, it should be answer choice C. Alright, so don't make silly little mistakes like that. Just make sure that when you're working through it, even though all you're doing is basically adding 3 plus 1, make sure that you put it in the right location, or else the whole thing's going to be wrong. Okay. Alright, on number 5, we've got which expressions are equal to 5 to the negative 3. Select all that do apply. So again, we don't know if it's going to be 1 answer, 2 answer, 3 answer. It could be all the answers for all we know. So we have to work through all of them. I'm going to start off with 5 to the negative 3. So the first thing I need to make sure I understand is that I have a negative exponent. So something that's equal to that is going to be 1 over 5 to the 3rd power. Because remember, we don't want to have a negative exponent. We got to move it to the bottom to get rid of that negative. Right? Another way you can write this is by having 1 over 5 times 5 times 5. Okay? And then if we actually take the time to multiply those numbers out, 5 times 5 is 25. 25 times 5 is 125. So we just need to go through and we need to match up which one of these is going to be equal to our answers. Alright, so to start off, 1 over 125, I see that one over there. That one's good to go. Negative 125. 1 over 125 is not the same thing as a negative 125. So if you compare it to money, if I say a negative 125, that means I owe somebody $125. If I say 1 divided by 125, that means I have 0.008. I don't even know what that is, 0.008 of a cent. So again, those are going to be two different amounts. All right, looking at negative 15, I can't have that one because that's not going to be the same. I do have my 5 times 5 times 5. I do have that listed over here. However, this has got an imaginary 1 under it. I don't need the 1 to be under it. I need the 1 to be over it. So in this case, that's like saying that you have $125, whereas this is like saying, again, you have 0.008 of a dollar. All right. Over here, we've got 5 times 5 to the negative 4. I only have one box checked. So in order for this to be more than 1, this has to be one of our answers, but you still got to prove it in order to be right. So I've got 5 times 5 to a negative 4. I can't have a negative exponent. It has to move. So I'm going to leave my 5 up at the top, move my 5 to the 4 to the bottom. Well, now I've got an imaginary 1 over this 5, so I'm going to say 4 minus 1 is 3. So I've got 5 to the third on bottom, and I've got 1 on top. All right, and even if you get to this point, you're still a little confused. Essentially, I've got 1 5 on top, 1, 2, 3, 4 5s on the bottom. Those cancel out, so I'm left with 3 on the bottom, and I got to have a placeholder on top, so that does match up. All right, so that takes care of that one. And hopefully you were able to see that. I forgot to look at my computer screen and the paper slid over, but if you need a second, that's what it looks like. All right, let's go to number 6. Whew, number 6 looks like a big one, so we're going to take these step by step. This is certainly one of those examples with the elephants. We're working it one at a time. Alright, so when looking at this one, we've got 3 squared being raised to the 5th power. So we'll use this for my left side and this for my right side stuff. So on the right side, I don't have to do anything. That's just 3 to the 7th. Over here, I do have a parentheses. They are touching the parentheses. We got the 5 on the outside. That means I need to multiply my numbers. So 3 to the 10th. That is not going to be the same thing as 3 to the 7th. That one goes down as a false. Alright. Over here, essentially, I've got a 1 underneath there. So I've got 3 to the 8th on top. We'll run out of room. I've got 3 to the 3rd on bottom. So now that we're dividing these, we're just going to subtract them out. That gives me 3 to the 5th. And over here, I got a big old mess. So I got a parentheses. They're touching. That gives me 3 to the 8th. Times 3 to a negative 3. I can't have a negative exponent, so I'm going to have 3 to the 8th over 3 to the 3rd, and this is going to work out to be, you guessed it, 8 minus 3 is 5. So I end up with 3 to the 5th, 3 to the 5th. So that one is going to fall in the true category. Alright, need some more space. Let's come over here. I've got 1 over 3 to the 4th times 3 to the 5th. Put my little imaginary 1 under it, and then times 3. Alright, so essentially I've got 3 to the 5th times 3 on top, or 3 to the 1st. On bottom I've got 3 to the 4th. Alright, so let's start putting this stuff together. Got 5 and 1, they're separated, so if they are separated, or side by side is how I said it earlier, got 5 plus 1, which gives me 6. And then that's over 3 to the 4th. So now that I'm dividing, I need to say 6 minus 4. That gives me 3 squared. Alright. Over here on this side, I've got 3. And then 4 plus 5 is 9. 9 plus 1 is 10. So unfortunately, 3 to the 2nd and 3 to the 10th, they do not match. Bubble that one in as false. Alright. Over here, I think we can save some space. We got 3 to the 3rd to the 3rd. I've got a parentheses. And you need to multiply those numbers. So we got 3 to the 9th times 3 to the 0, which is 1. So I just have 3 to the 9th on the left. Alright. On the right side, I've got 3 to the 3rd times 3 to the 3rd. They're side by side or separated. That gives me 3 to the 6th times 0. Well, anything to the 0 or multiplied by 0 equals 0. So 3 to the 9th is not equal to 0, so that one is going to be false. And then finally, for my last one, we have 1 over 3 squared times 3 to the 5th times 3 to the negative 5, 1 times 3 to the 4th. Looks more like a 34. 3 to the 4th over 1. Alright, so now we need to start putting this stuff together. So essentially I have 3 to the negative 5, 3 to the 4th over 3 squared. Alright, so what do I need to do with that negative exponent? If you're saying move it, you are correct. So you're going to leave 3 to the 4th on top, 3 squared times 3 fifths, or 3 to the 5th, and put those together. They are side by side, so what do I need to do with my exponents? According to my rules, I need to add them. So I've got 3 to the 4th on top, 3 to the 7th on bottom. I'm dividing, so I need to subtract those out. So I've got 1 over 3 to the 3rd. So that's going to be my answer for the left side. And then if we look at the right side, my answer is 1 over 3 to the 3rd. So right side matches the left side, so this one is going to be true. That was a lot of work for one problem, but that should take care of it for us. So again, if you need to, if I went too fast, anything like that, and that's the beautiful thing about having a recording. You can go back, you can rewind it, pause it, do whatever you need to do. If you can't see the numbers, just at least listen to my voice, and hopefully you can see enough that you can get it written out and use it as a practice problem. Alright. Number 6, let's go to number 7. And again, this is one of those that if you see it on, if you see a question on exponents on the state test, this is more than likely how it's going to be written because it covers the most rules possible in the smallest amount of space. So we're starting off with 2 to a negative 1. Can't have a negative exponent. It's in the top, so we need to move it to the bottom. We've got 4 to the negative 3 in top. Can't have a negative exponent. It has to go to the bottom. Got 3 squared in the top. It is a positive exponent, so I'm going to leave it where it is. Alright. Down the bottom on the bottom left, we got 4 squared, positive exponent, so it stays. Got 3 to a negative 2. The negative exponent can't stay, so it has to move to the top. And then 2 to the negative 3. Again, it's a negative exponent at the bottom, so it has to go to the top. Alright. Still going to follow my system. I'm going to start with the largest, or I'm sorry, the smallest bases, and then work my way up. So I've got 2 to the 1st on the bottom and 2 to the 3rd on top. So my first problem is really going to be that. So 2 to the 3rd over 2 to the 1st, I'm dividing. My rule tells me I need to subtract them. Again, if you forget the rule, just work it out. So 2's cancel. I got 2 left on the top. So 2 to the 2nd is my answer. So 2 to the 2nd goes on top. Mark them off. Alright, now let's go to the 3's. I got 3 squared and 3 squared. They are side by side. They're both on the top. So if they're side by side, I need to add. So 2 plus 2 is 4. So I end up with 2 squared and then 3 to the 4th. Mark them off. Alright, my next one, I've got 4 to the 3rd and I've got 4 squared. They're side by side. The rule says to add them. So 4 to the 5th. And that goes on the bottom. Alright. So now here is my answer choice. So when I look over here, 2 to the 2nd times 4 to the negative 5, that's not it. 2 to the 2nd times 3 to the 4th times 4 to the negative 5, that doesn't look like what I have, so that can't be it. Got 2 to the negative 3 times 4 times 3 to the 5th, that don't look right, so it's gone. I don't even know where they come up with that. 256 over 81, that's such a bad answer, we're just going to mark it off. So we've only got 2 options at this point. Either the test makers gave us a question that doesn't have the appropriate answer, or we solved for the correct answer, they just have it hiding over here in one of these spots. And that's going to be what we're looking for. So another way to write this, I have a positive 2 squared, and I have a positive 3/4. For some reason they don't want to put it in simplest form, to where your 4 to the positive 5 is on the bottom. So think about it, if we have a negative exponent and we move it, it changes to a positive. Well, what if we take this 4 to the 5th and we move it to the top? Then it becomes a what? A negative. So now we can look for the answer that says 2 squared times 3 to the 4 times 4 to the negative 5, and that's where they've got it hiding for us. Okay? So in my mind, I would say that's not simplest form because you have a negative exponent, but that's the way they want you to write it. So as long as you can pick it out of multiple choice, I know you can get to this point, you're good to go. Alright, let's look at part B. On all of this, essentially we just have a whole bunch of side by side. We don't have any exponents out here next to the parentheses, so we're just putting them all together. So we're going to find our 2's. 2 to the negative 1 times 2 to the negative 3. 3 squared times 3 to the negative 2. And then 4 to the negative 3 times 4 squared. Alright, so let's start putting them together. Everything's going to be side by side. So negative 1 and negative 3. 2 to the negative 4. 2 plus a negative 2 is going to give us 3 to the 0 power, which cancels out. And we got a negative 3 and a 2. So 4 to a negative 1. Alright, so my answer is going to be 2 to the negative 4 times 4 to the negative 1. So what I would like for you to do is to say 1 over 2 to the 4th times 4 to the 1st. So our answer either has to be that one or it has to be written like that. And when we scroll over here to the left, I want you to leave it with the negatives. So that's going to take care of the top one. Alright, number 8, the last one that we are working, last one that we're looking at for exponent rules. Match each numerical expression on the left with the equivalent value on the right, and we've got plenty of room on the bottom to work. So we've got 2 to a negative 7, or 2 to a negative 9. Remember your rules about negative exponents. You can't leave them where you are, you have to move them. So we're going to move 2 to the 9th to the top, move our 2 to the 7th to the bottom. Our division rule tells us we need to subtract, so 2 squared. Okay? So if 2 squared isn't one of our answer choices, we just need to take this and work it out. We're going to say 2 times 2, that's going to give me a 4. So there's my answer. Alright. On the next one, 2 to a negative 1 over 2 squared. Alright. Can't have a negative exponent. We got that negative person in our life. You got to get rid of them, move them out. So 1 over 2 squared times 2 to the 1st. Now we've got them side by side. 1 over 2 to the 3rd. So 1 over 2 times 2 times 2 is going to be 8. So this one is going to go to our 8. And again, if you need some help on this one, we're saying 2 times 2 is 4, 4 times 2 is 8. So all that's equal to each other. And finally, our last one, we've got 2 to the 7th times 2 to the negative 3. Can't have a negative exponent, so you can move it to the bottom, or if you want to, you can count them as side by side and just add them. Either way, you come up with the same answer. I'm just going to add them. 7 plus a negative 3 gives me a 4. I can hold my paper. So we're going to end up with a 2 to the 4th power. So 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that one takes us to 16. Alright. I know a lot of y'all are still having some issues on the exponent rules. So you do have some stuff on iReady you can work on. You do have some extra YouTube videos from different teachers, things that you can watch. If you need to, just literally go to YouTube and type in exponent rules. The other thing you can go to, there's a website called CUDA Software. They have some excellent worksheets. Go to CUDA Software and just look on the, I believe it's going to be labeled pre-algebra and algebra 1. There should be sections that have exponent, and then it's going to have hyperlinks underneath it. Pick some of those hyperlinks, click on it. If you scroll down far enough, the answer key will be at the bottom of the page. So like the first page will be questions, you can work through it, and then you can look at the second page and you can check your work. Alright, so that's going to take care of the exponent rules. If you have a question, make sure that you come by at some point, talk to me about it. We can go over some more problems. You can come into my acceleration periods, first and fourth period. Just let me know when you want to come by. We can keep working on them.